Hey everyone, today we are solving LeetCode problem 1422, maximum score after splitting a string. In this problem, we are given a string S of zeros and ones, and we have to return the maximum score after splitting the string into two non-empty substring. Okay, we will be given a string and we have to divide the string into two non-empty substrings, and we have to calculate the score. The score here is the total number of zero in the left substring plus total number of ones in the right substring. This is going to be our score. Let's work over the first example 0 1 1 1 0 1. This is the string given to us, and let's say we have to divide the string into two non-empty substring. So let's first consider one element in the left substring, rest of the element in the right one. The score is going to be total number of 0 on the left one are 1. Total number of ones on the right side are 4. So 5 is one option. If we divide at this position, the total number of 0 in the left side are 1, total number of ones in the right side are 3. So 1 plus 3, which is 4. So if we divide at this position, it would be 1 plus 2, which is 3. If we divide at this position, it would be 1 0 on the left side and 1 1 at the right side, 2. If we divide at this position, it would be 2 0 on the left side plus 1 1 at the right side, it is 3. So from all of these values, which is the maximum? Maximum is 5. So 5 is going to be our answer. Okay, but here in this case we checked for all the possibilities. Here we are checking all the possibilities. For every index we are checking the remaining substring on the right. So let's say the length of the string is n. For every element we are checking n into n minus I, which is going n square. So time complexity is going to be O of n square in this case. In the space complexity, we are not using any extra space, so it would be constant. Okay, let's try to look over efficient approach in this case. Let's consider the same example 0 triple 1 0 1 0 triple 1 0 1. As the string is containing only 0 and 1, so if we know the number of ones so far, we can calculate the number of zeros or maybe the number of ones after that. So here in this case we are going to take a prefix array of the number of ones so far. 0 1 2 3 4 5. This is the indices. So let's try first let's try to fill out this array. Okay, number of ones from the starting. We have 0 ones, 1 1, 2 ones, 3 ones, 3 ones, 4 ones. Now we have the number of ones as a prefix array. So at any position, let's say we have to check at the position 2. We have to calculate the number of 0 in the left side, number of ones on the right side. So let's try to see whether we can achieve these two variables from this prefix array. So at position 2, our left substring is this and the right substring is this. Okay. And from our prefix array, we can see that in our left substring we have two ones. So can we calculate the number of 0 if we had know the number of ones? Yeah, right. The length we already know that if I is the index I equal to 2, 0, 1, 2, the length would be I plus 1. So the length of left substring is I plus 1 minus the number of ones in the left substring, which is 2. So this will be our number of zeros. I'm repeating again that the length of left substring is I plus 1 because I is 2 here and we are starting from 0, and the number of ones we already know, which is stored in our prefix array. So from that we can directly calculate the number of zeros. So once we have calculated the number of 0 on the left side, now we'll try to calculate the number of ones on the right side. So the total number of ones and the number of ones in the left substring, if we have the total number of ones which is stored at the prefix of n minus 1 index, last index. The total number of ones are 4, which is prefix of n minus 1 minus the number of ones on the left substring. That we can also check from the prefix array, which is 2, equivalent to prefix of I. So this is going to be the number of ones on the right side. Okay, hope this is hope you understood this step. Like our score is number of 0 in the left, number of ones on the right. So for the number of zeros, we have the length of left substring minus number of ones. So it is number of zeros, which is 2 in the left. So for the number of ones on the right side, total number of ones in the whole array, this is total number of ones subtracted by number of ones on the left side. So we'll be left with number of ones on the right side, which is also equal to 2. The answer is 4. For index 2, answer is 4. Now we can check for all the index, from index 0 to index I minus 2, because at index 0 it means till 0 on the left side, and after that on the right side. Till I minus 2 is this index. So till I minus 2 on the left side, and after that on the right side, because both substring we want as non-empty. Let's try to write a pseudo code for that. Here if we have a look at the pseudo code, we are taking a prefix array where we will store the number of ones in the from the left. So for every index from 0 to less than n minus 1, because we want at least one element on the right substring, we will just first calculate the number of zeros and the number of ones. For the number of zeros, we can calculate using our prefix array. So till ith index, prefix I is storing the number of ones. So from the length minus number of ones equivalent to number of zeros. For 0, total number of ones in the whole string minus number of ones in the left substring, it equivalent to number of ones on the right substring. So ultimately we have to maximize these two values, 0 plus 1s. So for every index we are going to store the total score. So in this case we are just going to have a time complexity as O of n. We are just iterating over this array before that, like, we prepared the prefix array. So space complexity is O of n. But if we further look into this problem, this prefix I is the number of ones from the left, and we are also iterating from left. So this prefix I we can store here while doing the iteration. Okay, and this is, what is this? This is the number of ones, total number of ones. Total number of ones in this array can be pre-computed by doing one iteration. So if we do that, if we pre-compute the total number of ones and this we compute while doing the iteration, in that case we can optimize our time from O of n to O of 1, and optimize our space from O of n to O of 1, and our time will remain O of n. Okay, so we are going to implement this approach, O of n time and O of 1 space. First of all, let's capture the length of string as dot length. Now for we'll just implement the prefix approach, where we took the prefix array new int of size and I equal to 0, I less than, and I plus plus. For prefix 0 we have to like pre-compute. Prefix 0 is equal to s dot character at 0 minus 0. Prefix of I equal to prefix of I minus 1 plus this value. If it is 1, we are adding 1. If it is 0, we are adding 0. So prefix is holding total number of ones so far. Now let's iterate over our string I equal to 0 to I less than equal to n minus 2. We are skipping one character in the last. So first of all, we have to calculate the number of zeros and then int ones. Zeros on the left side. So first of all, the length of left substring is I plus 1 minus number of ones. So we will get number of zeros. Number of ones in the left substring is prefix of I. So number of ones on the right part. Total number of ones, which is prefix of n minus 1 minus total number of ones on the left substring, prefix of I. And now we have to maximize this value. Math dot maximum answer comma zeros plus ones. And ultimately we have to return this answer. Let's also initialize this variable. We have to start from 1. As dot character at I, not 1. Try to submit it successfully. Okay, but here in this case we used on time as well as on space to store our prefix array. If you analyze this logic, the main logic of our program, you can see that pre-I we can compute in this iteration and pre-n is the total number of ones in this array itself. So for that we can just calculate separately. Int total number of 1 equal to 0 for I equal to 0, I less than n, I plus plus. If s dot character at I equal to 1, total number of 1 plus plus. Now prefix of n minus 1 we are going to use total 1, and here also if s dot character at I equal to 1, we can just take variable 1. 1 so far equal to 0, 1 so far plus plus, and we are subtracting this value from these. Total number of 0 on left, total number of 1s on right, and now we'll get our answer. Let's try to run our sample test cases. Okay, submitted successfully. So here we have improved our space complexity to constant space and time to linear. Okay, hope you understood the problem. Thank you guys.